Students, assalamu alaikum. Today I'm going to solve in this video I'm going to solve question related to Cambridge Mechanics paper 4, and the question you can see here have taken from October-November 22 4-1, question number 6, Pulley related question. Now this video will be very important for you because this particular question I'm going to solve in 4 different ways, and you should practice those 4 different ways. Why? Because it's gonna better your instinct of understanding question. I mean, it'll be easier for you to understand the questions and to take the necessary step so that you can solve the question properly within a short time. All right, so let's start. At first, let's go through the question. Figure 6.1 shows particles A and B of masses 4 kg and 3 kg respectively attached to the ends of a light and extensible string that passes over a small smooth pulley. The pulley is fixed at the top of a plane which is inclined at an angle of 30 degrees to the horizontal. All the informations are also given in the question. A hangs freely below the pulley and B is on the inclined plane. The string is taut, that means the string is under tension, and the section of the string between B and the pulley is parallel to a line of greatest slope of the plane. I mean, that means the string is completely parallel to the inclined plane or inclined surface. It is given that the plane is rough, that means there is friction, and the particles are in limiting equilibrium. Find the coefficient of friction between B and the plane. So when you are solving questions where there is limiting equilibrium, the first important thing you need to identify is the direction of the limiting equilibrium. I mean, whether the limiting equilibrium here is in the upward direction along the slope or downward direction along the slope. You need to find it out. Why I'm saying this? Because depending on the direction of the limiting equilibrium, you can find out the correct direction of frictional force. That's also very important because the math will be comparatively easier if you can identify it properly. Now, the plane is rough and the particle are in limiting equilibrium. So think about it. There's 4 kg mass and there's 3 kg mass. So for example, consider a simple pulley system. Here there's an object 4 kg and there's an object, this is 3 kg. Now in which direction the system will move? The system will definitely move in this direction. Why? Because 4 kg mass, that's greater than 3 kg. So definitely it's going to move in that particular direction. Now, if you consider this section, think about it. Say for example, in question it is said that this surface is rough. Let's consider that is a smooth surface, and what will happen? This is 4 kg, so 40 Newton will act in downward direction. All right, and this is 3 kg in this direction, it will be 30 Newton. So that force is greater. So the system is supposed to move in this direction, provided that the surface is smooth. But the surface is not smooth. In question, it has said that the surface is rough and the object is in limiting equilibrium. Now think about it. So that means that 4 kg object will try to move that 3 kg object in this direction, but the system is not moving. Why? There is friction. So that means that 40 Newton weight is supported by component of weight of that 3 kg mass, mg sine theta, but that shouldn't be enough. For that 40 Newton. So that means there is also an additional force which is acting in this direction, and that will be the frictional force. Okay, I think you have understood it. So that means that 40 Newton is supported by that frictional force and component of weight of 3 kg mass. All right, so that means the frictional force is acting in downward direction along the slope. So that is very important. You need to find out the direction of the limiting equilibrium. All right, so now the question will be comparatively easier. Now let's at first draw the forces, all the forces that are acting. I mean, we didn't include tension force. We also need to include the tension force here. So let's identify the forces. Then we will find out the corresponding equation and solve the question. Now the weight of the object, this is acting in downward direction, mg or 4g. So it will create a tension in the wire. So it will create a tension in this direction. All right, so here there will be the same amount of tension. Here will be the tension. In this direction, the component of weight, mg sine theta or 3g sine 30, and also frictional force. So these are the forces. Now regarding tension, you need to always, in my earlier videos, I've always said that tension always acts inward. All right, so here in this pulley and in this object B, the tension will act inward always, and thrust always act in outward direction. Now let's make us the equation. So at first consider object A, 4 kg mass. Now it's in limiting equilibrium, so the resultant force is 0. So that means T equals to mg. Now here's one more thing. That weight is creating a tension force on that pulley in downward direction. So the pulley or the string is also applying tension force in upward direction. So that's what T equals to mg or T equals to 4g, which will be 40 meters. So that's the first equation. Let's consider object B. In case of B, that tension is balanced out by the component of weight and also frictional force. T equals to frictional force plus mg sine. Frictional force plus mg sine 30. So already we know that the tension is 40 Newton. Frictional force is mu r. Mass is 3 kg. So 30 sine 30. Now how do we find out the normal contact force R? That's very simple. R equals to mg cos theta. So that is the coefficient of friction. So that's quite simple. Now the mark is comparatively high, 6 mark, because at first you need to understand the question, the context of the question. So that's one. Anyway, so that's our final answer. Now let's move on to question B. Now we are going to solve the question B in 4 different ways. 4 different ways. Try to practice all of them, because it will really help you to build the instinct of understanding question within a short span of time, and also to take the necessary steps as quickly as possible so that you can solve the question within a short time, which is really required in exam time. Now in B, it is given instead that the plane is smooth and the particles are released from rest when the difference in the vertical height of the particle is 1 meter. You can see that the difference between the vertical height of A and B is 1 meter in the question. Use an energy method to find the speed of the particles at the instant when the particles are at the same horizontal level. When the particles will be at the same horizontal level, you need to find out the corresponding speed of the objects, of the particles. Now, this is what I can say an exceptional question comparatively, because you won't find out this type of questions much, because I have seen a lot of past papers, but this type of question I find very minimum number of questions. Anyway, so the question is, use an energy method to find the speed of the particles at the instant when the particles are at the same horizontal level. Why it's same horizontal? What is the meaning of same horizontal level? The meaning is, as the surface is smooth, the system will move in this direction. Why? Because weight of A is greater than weight of B. Now, A will come down a little bit. B will move in upward direction. At some point, they will be at the same level. At some point, they will be at the same level. We need to use an energy method to find out the corresponding speed at that moment. What should be the corresponding speed at that moment? We need to find it out. All right. Okay, so now how you can solve this question? Now be very careful that the distance, say for example, object A has descended X amount of distance. And when A is moving vertically downward, B will move along the plane by the same distance. Like say for example, it is coming X, it is moving in downward direction by the amount of X distance, and B will also move along the plane same amount of distance. Now be very careful that when it is descending X amount of distance and it is moving X amount of distance along the plane, that doesn't mean they're going to be on the same level. That doesn't mean they are going to be at the same level. So how you should do it? Now think about it. It is moving X amount of distance in downward direction, and B is moving X amount of distance in upward direction. So if this is 30 degree, this is also 30 degree. Now the point B is here, and it has covered a distance of X amount of distance. Why? Because if A move 1 centimeter below, B will move 1 centimeter along the slope, along the plane. If A descends 2 centimeter in downward direction, B will ascend along the plane 2 centimeter. All right. But the distance of A, vertical distance of A and B is 1 meter. So in that case, you have to write down X plus X sine 30 equals to 1. Why? Because if object A moves X centimeter in downward direction, then B is moving X sine 30 in upward direction. Why? Because this is 30 degree. This is X. This is X. So what is the corresponding vertical component here? The corresponding vertical component is X sine 30. Let me explain it again, because this is very important. This part, you really need to understand it properly. So A is descending by X amount of distance. B will ascend X amount of distance, but along the plane, along the slope. So that is X. And as this is 30 degree, this will be 30 degree as well. But initially the vertical distance was 1 meter. Vertical distance was 1 meter. So the sum of the distance covered by A in downward direction and covered by B in vertically upward direction, the sum has to be 1. If object A descends X amount of distance, object B will ascend in vertical direction by X sine 30. That means vertical component of X All right, so this is very important. So from here, if you solve this equation, the value of x is going to be 2 by 3. 2 by 3, not centimeter, it's meter. Now this is very important to find out the value of x, 2 by 3 meter. All right, now we have to apply the energy method to find out the speed. Now let's talk about the energy conversion. Now when the system is moving, A is gaining kinetic energy, B is also gaining kinetic energy, because right at the moment both of them are stationary, but after a certain time, if you release the system, they'll start to move, and definitely they'll gain some speed and they'll have some kinetic energy. So A will have some kinetic energy and B will also have some kinetic energy when they're at the same level. And gravitational potential energy of A is going to be decreased because A is descending down. And gravitational potential energy of B will increase because B is moving in upward direction. All right. So let me write it down in word equation. So it'll be easier for you. You don't have to write down in word equation in the exam definitely, but I'm writing it here for your better understanding. All right. So loss of GPE for A equals to gain in kinetic energy for both A and B, and also gain in gravitational potential energy for B. So that will be the energy equation. All right, so loss of gravitational potential energy of A is descending down by x meters, so that's going to be mg x or magx. Gain in kinetic energy, the velocity of both the object is same, so half mav square plus half mbv square. And gain in gravitational potential energy of B, that will be mbg. Now here you cannot take x because in vertical direction B is moving x sine 30. B is moving x sine 30. Now you know all the values, you just don't know V. If you make V as the subject, we'll get our answer. So 40 into 2 by 3. So you can add both of them. So m plus mb j squared 32 by 3 into sine 30. So from here, you have to make B as the subject. If you make B as the subject, the value is going to be, I'm not calculating it, the value is 2.1. Just use the calculator. So this is one way you can solve the question. All right. Okay, fine. So let's move on. Find out the tension of the system, and we will use the tension in the energy method to solve the question. So let's draw the forces here. So this is weight mg or 4g. It will create tension in this direction on A, and on the pulley tension will act in downward direction here and here. Now system is moving in this direction. All right, so for object A, for object A, 4g minus tension equals to mass into acceleration. For object B, t minus 3g sine 30. T minus 3g sine 30 equals to 3a. Now you have to solve them simultaneously. So if you solve them simultaneously, t cancel. We're getting 40 minus 30 sine 30 equals to 7. We are adding the two equations. If you solve it from here, you will get a value of acceleration. The value of acceleration is going to be 40 minus 30 sine 30 divided by 7. That's 25 by 7. 25 by 7. So that's the acceleration. Now, if you use that acceleration value in any of the equation, you will get the tension. So 4g minus t equals to 4 into acceleration. So 40 minus t, 4 into 25 by 7. So t equals to 180 by 7. Don't write down the answer in the decimal because we need to use that value again. Keep it in fraction form, then you will get the exact value in your final answer. Now we have got the tension. Now we will use this tension to find out the velocity gained by the object, but be very careful because this part there you can have a little bit confusion regarding which energy you need to consider and which energy you don't need to consider. That part is very important. All right, I'm explaining it, so listen to it very carefully. So I've got the tension. Now what is happening here? There will be loss in gravitational potential energy of A, gain in gravitational potential energy of B, gain in kinetic energy of both A and B, and also work done by the tension force. Work done by the tension force. Work done by the tension force on B. So all the necessary work done or energy changes we have registered here. We have all the energy changes that are possible in the system. We have listed it down, but the thing is, some energy we have considered repeatedly. How? Because the work done by the tension force on B, work done by the tension force, the force on B is converted to the gravitational potential energy and gaining kinetic energy of B. Work done by the tension force on B is creating the gain in gravitational potential energy of B and also the gain in kinetic energy of B. So when you are writing down work done by the tension force on B, you cannot write down gain in gravitational potential energy of B and gain in kinetic energy of B. Be very careful. I'm repeating it again. When in the equation, when in the energy method equation, you are considering work done by the tension force on B, you cannot consider gain in gravitational potential energy of B and also gain in kinetic energy of B, because this is the tension which is making it possible. So if you consider those three things, you are overestimating the energy changes of B. So be very careful. All right. So as we're going to apply the tension here or work done by the tension force on B, so we cannot consider gain in gravitational potential energy of B, gain in kinetic energy of B. We cannot consider that. All right. So let's write down the equation. So the equation is going to be, I'm writing it in word equation form. So tension, work done equals to force into displacement. Tension into X. Now we have to consider X. Why? Because A is descending X amount of distance in downward direction. B is ascending in upward direction along the slope by X amount. I mean along the slope, because the tension is acting along the slope. Work done equals to force into distance moved in the direction of the force. Distance moved in the direction of the force. So that means we need to consider the distance that is moved by B in the direction of the tension force. All right, so T into X. Fine. So 4 into 10 into 2 by 3. 4 into V square. The value of tension is 180 by 7 into 2 by 3. So from here, if we make V as the subject, the answer is going to be 2.18 meter per second. Okay, fine. I think you have understood. So let's move on to method 3. Now in method 3, what we are going to do here, in the first method, we did find out the value of X. Now, for finding out that particular distance, I mean the amount of distance that A has descended and B has ascended in upward direction so that they're the same level, you can find it out in a different way. I mean, in a different way other than the system that I followed in the first method. Let's consider B will move a vertical distance of Y. B will move a vertical distance of Y. So if B moves vertical distance of Y, the amount of distance it's going to move along the plane is going to be, so this is 30 degree, right? So let's draw the triangle here. So that is the slope, that is the horizontal level, and that is the distance moved in the vertical level, and that is theta 30 degree. So if this is Y, if I have considered that as Y, that will be Y as well. We need to find out the distance moved along the slope. So sine 30 equals to opposite by hypotenuse. So hypotenuse equals to Y by sine 30. So that means the distance moved along the slope. The distance moved along the slope is going to be Y by sine 30. Y by sine 30. And if it moves the distance of Y by sine 30, A is also going to descend in vertical direction by Y by sine 30. Because the amount of distance B is covering along the slope, will be the same amount of distance descended by A in vertical direction, in downward direction. So now we can write down the sum of Y by sine 30, that means distance descended by A in vertical direction, plus distance traveled by B in vertical direction, which is Y equals to 1. So from here, we will get the value of Y as 1 by 3. Y 1 by 3. Now again, apply the energy equation that we have used in the first method. And what was that? Gravitational potential energy gained by A. Gravitational potential energy gained by A. Sorry, loss of gravitational potential energy. Loss of gravitational potential energy by A. Gain in potential energy by B. gain in kinetic energy by both the object. So half ma plus mb. So from here we can find out the value of v. So from here, if you make v as the subject, it's going to be 2.18 meter per second. So this is method 3. Now let's solve method 4. If you can remember, in method 2, we have used the tension. We have used that tension. The value of tension will remain same, and that was 80 by 7. 180 by 7. 180 by 7. That was 180 by 7. So what is the equation? Loss of gravitational potential energy by A that will be converted to gain in kinetic energy by A and work done by tension on B. So T multiplied by the distance traveled by object B along the slope, which is y by sine 30. Be very careful. You cannot consider y here. Y by sine 30, because work done equals to force into distance moved in the direction of the force. Work done equals to distance moved in the direction of the force. So tension multiplied by distance moved in the direction of the tension. So 40 into 1 by 3 by sine 30. Mass of the first object is 4. Tension was 180 by 7. So from here, if you solve the equation, again the value of V is going to be 2. I'm not showing the calculation because you can do the calculation by your own. Let's not waste the time here. So this is the 4 method by which you can solve the questions, and you may have the question like, why do we need to learn this 4 method? Why not 1 method is enough? Now 1 method is definitely enough, but if you try to understand the 4 method, you will be able to understand a lot of things altogether just by solving 1 method. I mean, how to consider the work done, how to consider the frictional forces, how to handle the frictional forces, how to write down the energy equation in different format. All these things you can learn from a single math. I mean, you can have an insight of those equations and the systems and the approaches just by solving this question. So I think that will be very time efficient. All right. So thank you very much for this.